Hello everyone, my name is Latanya Maddox and I will be talking about the CBIR framework. So what is a CBIR framework? It's a content-based image retrieval which is used for retrieving digital images in a large database that have similar features such as color, shape, and texture. CBIR is used to locate images and videos fast and accurately. For this final project, I will show how CBIR can implement CBIR framework for your business. The applications of the CBIR, pretty much you can use it with medical images like CAT scans, MRIs, and ultrasounds, forensic images like criminal images, fingerprints, scene images, satellite images for analysis and predictions, and general images like your mobile phones and computers that you may have thousands and thousands of pictures of. So how to search images in the CBIR, it will be color, shape, and texture. And in the following slides, I will discuss each one to give you an understanding what each means. So to find the color with similar color features, you must use a color histogram for each image to identify the pixels within an image. And then a color histogram shows the number of pixels that have colors in an image. So color searches usually require comparing color histograms. So finding images with color does not need to know the image size or the orientation. Shape. The shape for CBIR refers to a region of an image. So the shape the shape is determined by segmentation and edge detection of an image. You can use edge filters and morphological filters to identify shapes of an image. The texture is hard to define, so to identify texture of an image, you must use a two-dimensional gray level variation. So in the following slides, I will discuss the implementation of CBIR using a query by example and a demo of my source code. So the first step, you need to normalize the 6-bit color code histogram counts. So in this step, you must convert the RGB image to a 6-bit color code image to reduce all the colors into a 64 color groups due to it being millions and millions of colors out there in the world. And histogram counts use color distribution to represent an image. To make histogram counts comparable, you will have to normalize the counts by the size of the image in the dataset. Step 2, distance measure based on visual features. In this step, I measure the distance between two visual feature vectors to examine the similarities between two images. And in the project, we used a distance measure called Euclidean distance, which measures the distance, a straight line distance between 2 points in the space. Use the function getDistance to measure to calculate the distance between two visual features vectors of two images, which is the query image and the target image, to establish a CBIR framework. Step 3, now it's time to rank the target images based on distance. So now that I extract the color, shape, and texture and measure the distance and create a CBIR framework, now I can rank the target images stored in the database. So to rank the target image, I had to use a sort row algorithm to rank the images in ascending order of the region. I sorted the distance from ascending order and from shorter to larger similarities, but the focus is on the index instead of the distant values. So now it's time to retrieve the top 20 images. I used the code index 120, in which you will see in the demo. Last and final step, I had to create a graphical user interface, figure 1, to display the top 20 images. In order to display the images, I had to scan the import folder to retrieve the images. And then to display the query image, I had to use a 5x5 subplot. And then to display the first target image, I had to do a 5x5 subplot as well. The first, I think, 6 images. Next step, I had to load the target image file using the top 20 index file list, and you will see the query image and the top 20 similar images. So here we have the RGB26CC fast function. So in the slides, I explained about converting an RGB image to a 6-bit color coded image. So I used a function called the RGB26CC fast to apply the conversion. And as you can see in my code, I used bit shift and a base conversion, a polynomial method, um, to receive an accurate result with converting the image. I use bit shift to apply the first 2-bit, and then the polynomial method code is the intensity range from 0 to 63. So in the get his counts code, um, as I explained in the previous slides, the histogram counts are used for data distribution to represent an image. There are three parameters here. I have the IMG, which is the gray level image, the NBin, which is the number of bins of the image, and the range is the intensity range, the minimum and maximum vectors. So to calculate the bin width, I had to subtract here. Calculate, I had to subtract the maximum from the minimum, and start from 0, and then I had to add 1 so it could equal to 64 bins. And then as you can see, to make the histogram count comparable, I had to normalize the hist counts by image size using where is it at? Right here, counts equals counts for every number of elements of the image G. So to apply the histocounts, I need to read an image from the data set. So let me go here. The convert RGB image to 6-bit color code, and then next I gotta get the hist count. And here the visual feature will be shared in my DB database right here. Now I can use a for loop to process each database. Data set, and to get a data set size, you have to um, scan the import folder by creating an import path and separate the folders. You will use the file set, which I used here. And these two right here, this is the parent, so that's my final project folder that is starting with. And then finally, I have to save the DB file in the database folder, then to the meta folder. So here, to measure the distance based on visual features, you will have to create a get distance function to calculate the Euclidean distance between two vectors, as you can see right here. And then after all that, I created a script to implement the QBE based to the CBIR framework. So here I retrieve a query image and the normalized histogram counts visual features to represent the query image. So then I had to load it, and I created a D matrix to store the distance between query image and target image. So right here is my D matrix, and then I compare the query image to target in my for loop. So next I need to rank the target images by distance. So I did it in the index. So I sort the rows by the index, and then I retrieve the top 20 index. So that's the top 20 is pretty much is the most similar target images that's similar to the query image. Then here is where I did the subplot to display the target images as well. And so my example will look something like this. So here's my query image, And these are my other most similar images to the query image. So that will be it for my presentation, and I just want to thank you guys for looking.